In this screencast, I'm going to show you how to create and interpret a box plot. Box plots are a special visualization technique in statistics. Now, typically all you include is the box, and I'll show you that in a couple examples. We have this box. The top line is the third quartile of your data. The bottom of this box is the first quartile, and then you've got this line in the middle that represents the median, and it's not in the exact middle. It's somewhere towards the third quartile or the first quartile, depending upon where exactly the median lies in the set of data. We calculate the interquartile range, IQR, as the difference between Q3 and Q1. And then what we do is we multiply the interquartile range by 1.5. We go above the third quartile, a distance of 1.5 IQR, to identify something known as the upper fence, or F3. And then we go down below the first quartile, a distance 1.5 times IQR, and that's identified as this value F1, which is the lower fence. So we have the upper fence F3 and the lower fence F1. Now we have these whiskers that extend from the middle of the box vertically, and they go to the last data point within 1.5 IQR, so below the upper fence, or F3. So that vertical whisker on top goes all the way to the last data point that's below F3. The bottom whisker similarly extends down to the last data point that's above our lower fence, and that's how we can set up this box plot. Any data points that lie above F3, the upper fence, or below F1, the lower fence, we denote those as outliers. And usually we make an asterisk or some sort of other unique shape. So here in the bottom, this is an outlier in our data. I'm going to show you how to generate these in Excel. In Excel, these are known as Box-and-Whisker plots. There's lots of different software tools that will generate these automatically for you, or you can always draw them by hand. I want to show you how to generate these in Excel. So I've got some data here in a file called boxplots.xlsx. I'm going to go ahead and name. So I'm going to do Control-Shift down. I'm going to name that data. So the box plot tool, when we do it, is automatically going to do all this for us. But let's just calculate the first quartile, the second quartile, and then the interquartile range. So this is, if you watch the screencast on quartiles and percentiles, we can use the EXC. That's the most common way to do this of our array. And then this is going to be our third quartile. We can do the same thing for the first quartile. I'm going to put in my data and 1. And those are the third and first quartiles. The interquartile range then is just the difference between the third quartile and the first quartile. And in this case, that's 0.76. Let's go ahead and calculate the upper fence and the lower fence. So that is just a value, and I'm going to go ahead and just name these. I'll name this one third, and this one is going to be named first. I'm also going to name this cell IQR. The upper fence, therefore, is then the third quartile plus 1.5 times IQR. And the lower fence is equal to our first quartile minus 1.5 times the IQR. Anything below 38.16 then in our data is going to be deemed an outlier. Anything above 41.2 is going to be also deemed an outlier. So let me show you how we can automatically generate these box plots in Excel. So I'm going to go ahead and just select my data over here. I'm going to go into Insert. I'm going to go into Recommended Charts. I'm going to select All Charts. And if you go down to the bottom here, it says Box and Whisker. So select Box and Whisker. We can go ahead and click OK. This is our box plot. You notice that we're identifying 2 outliers here. There's an outlier if you hover over with your cursor. There's an outlier at 41.54, and there's also an outlier down here at 38.13. So it's a nice way to identify outliers. You can also hover over here to see the last data point before the fence. In this case, it's 40.35, and then the lowest data point before the low fence, which is 38.66. What about if we have multiple series? That's one of the advantages of using a box plot, is that you can easily visualize different series next to each other. So I've got some data here, burritos. We have 5 replicates. These are the weights of burritos from 4 different restaurants. So to make this box plot that shows the 4 different series, I'm going to highlight the data including the restaurants. I'm going to go up here to Insert, Recommended Charts, as we did earlier, All Charts, and then Box and Whisker. I'm going to go ahead and click OK. Now let's delete the chart title. I'm going to see this 1 at the bottom. There's not a good way to add the labels, so Illegal Pete's, Qdoba1, Qdoba2, and Chipotle on the x-axis down here. And in fact, that 1 is kind of, we want to get rid of that. So I'm going to go ahead and right-click, and I'm going to do Select Data. And the axis labels here, I'm going to edit. And I'm just going to, this is just kind of a trick or a workaround. I'm just going to click in any cell that's empty. And then we can click OK and OK again. And now we've removed that. To add in a y-axis label over here for the weight of the burritos, I'm going to add in axis titles. Let's go ahead and delete that axis title down there. And then I'm going to change this to weight in grams. Now half of this plot is just wasted space, so we want to expand those. I'm just going to go over here, right-click, Format Axis. I'm going to change this to a minimum of 450 and a maximum of 750. And there we've got kind of a nice scaling there. The last thing I'm going to do is add in a legend so we can visualize the different distributions of the different restaurants there. So this is a nice box plot that shows multiple series. Another way to do this is a little bit different, but we can copy the data. I'm going to go over here to a new worksheet. I'm going to paste. Now, if you kind of transform the data such that they're all stacked on one another, like this. So I'm gonna put the data kind of stacked on one another. And then what I'm gonna do is we have to apply that restaurant or label adjacent to the data point. So this is how you prepare it for the alternative form of the box plot. So I'm gonna copy here, and we're gonna put this into these 5. Copy Qdoba 2, put it into these 5, Control V, and copy Chipotle and put it into these 5. And then I can delete these up top. And if you want, you can just go ahead and remove all the formatting here. So we go over here to this Clear Formats, and we've got our data. Once you have it prepared in this format, you can go up here after highlighting all the data, Recommended Charts. We can go to All Charts, Box and Whisker. We can click OK. And now what it's done is it's created different, we have our labels as kind of columns in here. So both of these methods will work. You probably would want to scale this as well. So both of these will work. I think I prefer this first one over the second alternative. So in conclusion, box plots are also a great way for comparing multiple data sets. And finally, I just want to remind you to be wary of removing outliers. Here on the right is an actual burrito from Chipotle. If you look at this box plot over here on the far right for Chipotle, the average is somewhere around 525 or 530 grams. And I got this burrito once. It was a massive burrito from Chipotle, 951 grams. So that'd be way off the chart here in mass. That's clearly an outlier. So if you would have identified that as an outlier, you would have just eliminated that. You do occasionally get outliers that are actual measurements, and you should probably leave them in your data sets. But if you get an outlier that you can track down to some sort of clerical error, or maybe you wrote it down improperly, then those are the outliers that you should remove. Thanks for watching.